Hello, everyone. My name is Ignjacevic, and I'm a PhD researcher at the Free University of Amsterdam at the Institute of Environmental Studies. And today I'm going to be talking to you about the recent research we've been doing in the field of time of emergence of climate change. And let me just share my screen real quick with everyone. So, yes. Here it is. So, this is a very interesting work that we've been doing, and that mainly for the reason that we've been looking for a measure of climate change for a very long time. So we're always talking about these hazards. We're always talking about how severe climate change is going to be, but the only measure that we've ever had to account for that in the world of integrated assessment models that we're using are monetary. So that's sort of the problem that we've had for the past couple of years, and this is also something that's inherent to other integrated assessment models. For example, if you take a look at the very famous DICE model by William Nordhaus, and quite some other models, we're always talking about monetary damages expressed in terms of dollars or euros or any other currency for that matter. But what we're interested in is presenting you with something that's a little bit more close to the actual country's capacity to cope with climate risks. So what if we would, for example, tell you how bad are climate damages compared to the 2008 crisis, or the oil crisis, or any economic crisis for that matter that has occurred in the past, let's say, 50 years. So we could imagine that this could be quite it would be quite difficult for us to understand these damages when they're expressed in terms of dollars, especially if we're dealing with different countries. So we want to compare how badly is climate change going to hit, for example, India compared to the United States. When we give dollar values, we don't really put it into perspective. So we could easily imagine a scenario of what would happen if climate change would be so severe that it would be worse than anything that our economies have experienced in the past 50 years. So here's where we actually arrived at a very interesting estimate that has been around for quite some time now, and it originates from climate sciences, and it is the notion of the time of emergence. And this is the key in our analysis, and this is what we're going to be referring to as the tipping point. So we can think of this tipping point as the point in time in which these climate damages would be like nothing that we've seen so far. So more formally, we could say that the time of emergence is the year of exceeding extreme historic economic shocks for any region in the world, for any country in the world. We can do that now. So for example, what is the date when the impacts of climate change in Germany would exceed some very, very high value of its past impacts? For example, the 2008 crisis. And this concept has been around, as I mentioned, in the climate sciences, where scientists have looked at past variability of temperatures. For example, we look at how does temperature vary in the past 100 years. And we see that the temperature is within some certain bounds that in a way it is limited. It's not exceeding these past bounds. But at some point we can see that this threshold, these extreme values that have occurred in the past are starting to get exceeded and are expected to be exceeded even more in the future. So this is really the point that we're looking for, but in terms of economic impacts. So what is our methodology? We're using an integrated assessment model similar to the one that William Nordhaus has used, the DICE model, but our version is actually very local. So we can map our impacts on a 50 by 50 degree scale. We can also project these impacts for in the current century, so until the year 2100. And we can also do this for many different climate scenarios that are consistent or that are listed in the IPCC report. So RCP 2.6, 4.5, 6, and RCP 8.5. So what we would like to do is we would like with our model to project future impacts of climate change. And we do this in terms of monetary values, as we've always done. But then we also want to generate a database of past impacts for all the countries in the world for the past 50 years. And we want to be comparing our impacts to the past impacts. We want to say, okay, our future impacts, are they worse than what has happened in 1960 in a particular country, or 1970, or any year? We would map these impacts and we would say, at what point in time would these impacts exceed this set threshold? And this threshold you can set yourself. You don't need to take the most severe impacts. You can also take impacts that are quite less severe, like 50th percentile or something that's sort of a medium shock. And with this, you can map for all the cells in the world the expected time of emergence of climate change. What is also interesting in our model is that we take into account the so-called urban heat island effect. And you may be familiar with this concept, but basically the urban heat island is a phenomenon that occurs in urban areas, in cities primarily, where the urban environment is heating more than the rural environments around the cities. And this happens because there's a lot of traffic, for example, in the city. There's a lot of exhaustion. There is many more people living there. There's also reflections from the buildings, also all sorts of things that play a role in higher temperatures in cities. And we have also modeled this within our local model because we're very interested in local impacts, and cities are projected to be impacted the most. So now let's look over some results. As you can see, we can map this for different cells, and we can focus, let's say, firstly on Europe. And we can see on the left-hand side the impacts if we were to abide by the Paris Climate Agreement. And we can see that almost no cells in Europe have exceeded this impact. Whereas if we looked at the right-hand side, we see the impacts for the RCP 8.5 or the standard scenario that we're currently in, with no climate policies, with no mitigation or any sort of intervention. And we can see that many cells in Europe, and especially the red ones, you see those are like really highly populated cities in Europe, and they're very highly impacted. So for a lot of these cities, you can see that the effects, the time of emergence would come even in the first half of this century if we were to not do anything about climate change. We can also do this for other regions. So you can see in Southeast Asia, some areas have already in our model exceeded the time of emergence, and that is potentially because those areas maybe didn't have high impacts before, high economic impacts, so the climate change has already exceeded those effects. But you can see it's much more severe, and basically all of India is expected to be impacted, mainly due to high population and also high climate damages in that region, in that particular region. Now moving on to the US, we can see that it's a very similar story to Europe. It's a developed country, but we still see that quite a lot of areas in the US will be impacted, very specifically the major cities on the east and the west coast. You can see that, again, the impacts are, the time of emergence is expected to occur in the first half of the century. And with this, we can already arrive at the conclusion that using the measure of time of emergence, we can see that very developed world regions are also at the risk. Previously, when we were using simply the monetary values, we could see that, basically the developing world would be most at risk. But now we can see that also highly developed areas who have had little economic shocks compared to the developing world are also expected to suffer in the current century. A little bit more of the results. Now we can also focus on some specific cities, in this case in Europe, and we can map our projected time of emergence for several cities for many different scenarios. So if you were to look at the right-hand side, we can see that, again, the Paris Climate Agreement, if we were to abide by it, we see that a lot of these lines are turning vertical around the middle of the graph. And that means that certain high thresholds are never exceeded with this climate policy. So this means, for example, that Berlin would never exceed the 85th percentile, or something that will be considered very high damages in the current century if we were to use the RCP 2.6 scenario as a measure. But the picture is quite different if we keep doing what we're doing currently. And on the right-hand side, we see that that very, very high impacts, let's say the 90th to 100th percentile, so very, very severe damages, are exceeded in almost all of these cities by the year 2070. So that there's a clear sign that if we account for the urban heat island, which is shown to affect all these major cities, we do see that the climate damages are quite severe. So finally, to just conclude, the main conclusion that we can draw from our analysis is that unprecedented impacts of climate change are going to occur if we continue doing as we are, and very specifically, the developed world is also going to experience this using this this measure of the tipping point that we have developed. However, if we employ some climate mitigation strategies, so if we try limiting our greenhouse gas emissions, we can delay these risks for several decades. And finally, if we were to abide by the Paris Climate Accord and limit our temperature rise and under 2 degrees, we can delay all of these effects until well past the 21st century. And this finally can be seen as buying ourselves time for climate adaptation. So if we were to employ climate mitigation, we can buy several decades of time to finally adapt to climate and to limit these very, very severe damages from climate change. So thank you very much.